Welcome back to the Macho Black channel. We are still on the live table and we are doing questions. So the first question is calculate the probability of survival to age 60 exact using ELT males for life age 45 and a half, exact using two approximate methods. So for this course, there's two approximate methods. The one is the uniform distribution of life, and the other is constant mortality of life. So the ask is to calculate TPX where you have some non-integer value. So this is the ask. The age is 45 and a half, and then he needs to live for 14 and a half years. So we need to break this up so we can take the half to age 46. And then once he's age 46, we can do the 14 years as well. So this is then what happens after we've broken up the half and the 14. So the second part is fairly easy to calculate. It's TPX, L x plus T over LX. And then we have our LX values in the ELT males table. So you're using exact and not select, and then we get that value. And then the first one is the uniform. Yep. The first part that we is the uniform distribution of deaths, right? So in this case, we are just assuming that the TX, the PDF of life is constant. So we get a mark for this. Then whenever we think UDD, the formula that should come to mind is what we did on the summary, which is the TQX formula. And then we'll just use 1 minus that to get the probability, right? So in this case, our T is 1 and our S is half. And then we just substitute that into these values and then pull values from the life table and then get your answer, right? So P to the half, that, that. Fairly simple. And then we'd just multiply these two versions, this and that, giving us that. So this was a 5-mark question. I think we should have 3 marks or so. Then the second part of this is that we assume a constant force of mortality over the years. So the first part, right, is to calculate the force of mortality, right? So there's two formulas that we have. We have that formula for force of mortality. And that's formula for constant force of mortality. So um, we would then use this first one. We would have to use this first one to, and the second one, and that basically be equal. We'll take the P from the tables, which is P45, to calculate the U. And then once we have the U, we'd just calculate that half probability. We'd use this to calculate half the probability. Happy. So this is the first line, which just says that is equal to that, and then this is equal to that, right? So minus half. So 1 minus half is half. With the negative, it's negative. Then you have U45 is equal to P to the minus half, because we're doing it 1 minus half, right? And so it should actually be P to the half, if I'm not mistaken. So this half will fall, and that half will fall. And then you'll just have a negative mu. Like that. So that's negative ln 1 minus 45. So this was ln P, because the half has fallen. So that's ln P 1 minus Q45. And you substitute for the Q, you get your U, and then we can now calculate the probability of half, because we have the force of mortality, which is E to the minus half that, and then we have the probability value, and then we multiply the two. So, I mean, if your paper is out of 100, then we are 5% there, or at least 4%. If, say, you miss one of the assumptions, or something they were really looking for. But I mean, it should be some easy marks. The second one says a graph of f of t is the probability density function for the random future lifetime t of 0. It's plotted in a vertical axis with t on the horizontal axis for data taken from the ELT15. You're given that f 0 tu of ut, you observe that the graph rises to a peak at t is equal to 80 and then falls. Explain why the graph falls. So you just need to focus on the fall. So the graph looks like a normal distribution, but there's just humps at inception, then it normalizes, then there's an accident hump, then it goes up from your mid ages, it goes up, and then it goes down. So you just need to explain why it goes down. And so as t increases, the force of mortality increases, right? So that's your first line over there. And but the probability decreases. So TP0 decreases, right? So that's at age 80, right? So force of mortality will increase, but the probability, well, throughout the lifetime, the force of mortality will increase. But the probability that you make it to the next age will decrease as you get older, right? And then at age 80, right? At age 80, approximately. So the approximately came directly from the answer in the exam. I didn't have that. The decrease in the probability is greater than the increase in the force of mortality, right? Because this is a product, right? Hence, the whole product will decrease. There we go. There we go. fairly easy as well, but a bit confusing. But you just need to remember that mortality graph. Right. The third question is express Q40 in words. So this is the probability that a life age 40 dies between, so they live for 45. So it's that they die basically between age 45 and 55, right? Probably that like so you live for and then die within, or the probability that a life aged 40 dies at age dies between age 45 because you live to 45 and 45 plus 10 is 55. It's the same thing, right? Just phrased differently and then calculate it, right? So that formula, the formula for this should come to mind. And that's the formula. So that's n dash mqx is equal to that. And then this is just writing that in P. But I mean, they're giving us AM92, so we can write it in life terms. So we have L45, because it's 40 plus 5, over that, 55. Substitute the values. Bob's your uncle. Then that's another 2 marks, right? It's 2%. Moving on to the fourth question. It's a bit weird. So calculate to the nearest integer the lower quartile of the complete future lifetime of a person aged 25 exact, who is subject to mortality according to EOT 15 males. So complete future lifetime is from now, well, the remaining years that you have. You need to check the summary in the summary video for this chapter. Is the outstanding life that you have, right? So the lower quartile is like what? The lower quarter or the lowest 25, right? So we're saying 25% of people live than a particular age, right? Because that, so we are saying that 25% of people need to live to this age T. So we're trying to find this age that 25% of people live to, right? The lowest 25% of people live to. So that, we'll say TQX is equal to 0.25. And then we can say L25 over T over 25 is equal to 0.25, right? It's just the same as 1 minus that and 1 minus that. We haven't changed anything in the equation. We're just trying to solve for T. And L25, we just take from the tables. And then we're left with L25 plus T, right? And then we just solve for your L25 plus T. And then we have that it's 0.98, right? So we will take the lowest value, right? In the tables, we have L74 and L73, right? So we need to take the nearest integer. So this is, I'm guessing, close to that, L73, right? I need to check the answer. But I mean, say L, we can say 73 minus 25 is 48, and that's the lower. I mean, even if you use 74, right, the worst you can do is lose a mark or half a mark. But I mean, that's the gist of it. The gist is not in the answer. I can tell you a story where I wrote a paper without a calculator and I still passed. So that's how I know that the final answer is not important. Right, define and calculate um, Q. So it's basically what we did, but it's now in select format, right? So this is a life age 41, dies between age 46 and 56, right? And with 1 year duration into the population, into the life population or something, right? Or you can say that age 41 with 1 year duration since the selection process is alive for the next 5 years and dies within the next 10 years. Something along those lines, right? And then the calculation is simple again. We have that NQX and bar QX that will just um, add some selections to the X just to make us feel better. But from the summary, we know that I think X plus 2 is equal to LK. Okay, I'm going to leave this out because we'll just focus on that. But I mean, if you were using the piece, you'd obviously put in the piece there. And we have the formula there. So L45 plus, so it should be L40 plus 1 plus 5, because it's 5 years, right? Uh, Same here, should be plus 5. Then you have your L46, L56. Substitute, get the value. The important thing is that in the select, when you're choosing the select, right, you would use, so it's AM92 select, right? Um, your LX, your LX, so because we are at age 40, but we're doing age 41, right? So we would go to age 41, and then we take, so when you're choosing select values, it's a bit tricky because like your LX40, your L40 plus 1, it won't be in row 40, right? But it will be in row 41 because it's written as LX plus 1. So that is the trick. You'll just find it in row 41 as well, not in row 40 plus 1. Okay, so this is the last one that we'll do. Explain what the following represents. So this is what the number of lives, right? Alive, A, number of lives alive at age X plus R, right? With a duration of R since the selection process. Okay. And then B is this is what the probability. We've been discussing this for the entire question. Now, so this is a probability that life age X dies between age X plus N and age X plus N plus M, right? And the last one, dx again, number of lives that die between hx and x plus 1. All right. Yeah. So of Lx lives alive at x. So, I mean, there's still some questions, but let's stop here. Right. If you want some more questions, give me a ring. Then I can give you some questions or just write a comment or send me a message, whatever. And yeah, hope this one pretty much helped. There's the summary as well. If you want the summary, just give me a ring from the previous video, and then we can take it from there. But we need to practice, 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 practice. We need to remember those formulas, spend a day or so just recalling them, understanding them. So it's just easy for you to call them out in an exam. Yeah, we'll see you on the next video. Cheers.